Okay, so now we should be able to go ahead and finish. We should have plenty of room now for the recording. So we factored, this was already factored, right? Because nothing would come out. We're still in 5-1. The last part of 5-1 is factor by grouping. So this is kind of a new concept. And factor by grouping is when you have 4 terms. So we're going to now learn how to factor by grouping. This is a very, very important technique. We're going to use this a lot in the next sections as well. I'm going to pick problems from the textbook. And this way they factor out nicely. And if you don't have your textbook with you or don't want to dig it out, I'll write them up on the overhead. So we're now going to look at a few of these where we factor by grouping. And factor by grouping is where you have 4 terms. And terms are separated by addition or subtraction. When we go to factor, we factor based upon the number of terms that we have. That kind of tells us how to approach the problem. So when we have 4 terms, we have to use factor by grouping. And I'm going to pick a few of these from our textbook, and this is on page 348. We're going to look at question 51. And this is mx plus qx plus my plus qy. Now, first thing I do is I count the number of terms. So it looks like if I count the number of terms, terms are again separated by addition or subtraction. So it looks like I've got 4 terms total. So I'm going to factor by grouping. And what we do is we group the first 2 together and the last 2 together. So let's first look at the first 2 terms together. And when I look at what I've got underlined there in green, only look at the underlined part. I've got mx plus qx. So what can come out? They have what variable in common? They have an x in common. So what's going to be left over? M plus q. The next 2 pieces, we group those together. What do they have in common? Well, they both have the variable y in common. So we factor them by grouping. We group the first 2 together. We group the last 2 together. Now, once we have done that, we look and the parentheses should be the same. So once we factored by grouping, then we look at our parentheses, and our parentheses are the same. So that means we're going to factor out an m plus q. These are the same. We factored them out, so they're gone and gone. And what's left over now? If we cover them up, x plus y. And that's as far as we can go. And we're going to use factor by grouping a lot in this section and also in the next section in 5-2 as well. So that was 51. Let's look at 54. (54) is 3ma plus 3mb plus 2ab plus 2b squared. And so the first thing we look at is we look at all of it together. Nothing comes out, right? because there's no variable in every single piece that's the same, and there's no numbers that have anything in common, because you've got 3's and 2's, they have nothing in common. So you always look at the entire part first to see if you can factor out a greatest common factor. We can't do that. How many terms do we have? 4. How do we handle 4 terms? Well, when we have 4 terms, we factor by grouping. So we're going to try and group the first 2 together. Now, you may have to switch the order in some cases, but this one we don't. We can just factor it by grouping with the same order as it is. So now when we look at these 2 together by themselves, they have a 3 in common, and they have an m in common. 3 and an m comes out. What's left over? A plus b. Next 2 pieces. What do those have in common? Well, it looks like they have a 2 and a b in common. What's left over? A plus b. Now, those parentheses should be the same. If they are not the same, you made a mistake. Or factor by grouping just doesn't work for that one. But in this case, these groupings are the same. So that's going to come out in front as an a plus b. And what's left over? 3m plus 2b. Try another one. Let's look at 61. Question 61 is m cubed plus 4m squared minus 6m minus 24. So again, we have our 4 terms, so we factor by grouping. So the first 2 pieces, what can come out of here? Well, if I factor out what's in common, what do they have in common? They have an m squared. And what's left over then? M plus 4. The next 2 pieces. What can we factor out of here? Minus 6. What's left over? When you factor out a negative, what happens to your signs? When you factor out a negative, the signs switch. So that becomes an m plus 4. Now, are my groupings identical here? Yes, they better be identical, or else you made a mistake. So that's m plus 4, and what's left over? M squared minus 6. And that is your final, finished answer. Nothing else will go any further on that one, and everything has been factored. Okay, let's do a little bit more complicated one. How about 68? Question 68, we've got x cubed, y squared, minus 3, minus 3y squared, plus x cubed. Now on this one, we're going to have to rearrange the order. Why am I going to have to rearrange the order? Well, if I try and look at these 2 together, if I just look here, there's nothing in common, is there? Right? And I look back here, there's nothing in common. So I'm going to have to rewrite them in a better order. So let's see what can go together. Well, this piece here, I think could go with that one, right? Because they're both x cubed. So let's go ahead now and rewrite it in a little bit better order. So let's rewrite this as x cubed y squared plus x cubed. And then we'll write the y squared next. So then we've got a minus 3y squared and a minus 3. So why did I do that? I did that because the order in which it was given didn't work for us. Because these first two have nothing in common, but the last two, they do. So I just rewrote them in a little bit different order. Now, once they've been rewrote in a different order, now we can see what they have in common. And now that they've been rewrote, well, the first two pieces, what do they have in common? Can someone tell me? These have a what in common? They've got the same variable, and what can I factor out? Just look at the green part here. These both have an x cubed in common, right? Just to make sure we're on the right track. So these have an x cubed in common. So that's going to come out. Make sure I copied it down correctly, which I think I did. Yep, everything looks right. Just double checking things. What's going to be left over if I factor out that x cubed? If that x cubed came out, that left you then with a y squared. Those completely go away, but we always leave a 1. So if it comes completely out, you leave a 1. Now the next two pieces. If it begins with a negative, you always want to make sure that you factor out a negative. So these, we can go ahead now here and factor out a negative 3. So if it begins with a negative, you factor out a negative. That's our rule. And if I factor out a negative 3, that leaves you with a y squared. Negative 3 and negative 3, when you divide them, that leaves you with the positive 1. So we rewrote it. Now we factored it by grouping. Our last step is to make sure that our parentheses are the same. Are these parentheses the same? Yes. So what's going to come out in front? Y squared plus 1 comes out in front. Gone and gone. Cross them off if that's helpful. Those are gone. Okay, and what's left over? What's left over is x cubed minus 3. So that leaves us then with an x cubed minus 3. And that's as far as we can go. Factoring is just kind of a puzzle, figuring out how the pieces can go together. You may have to rewrite them in a slightly different order, rearrange things to make it work. Let's try another one. How about 72? So for 72, we have a 12 minus 6q minus 18p plus 9p cubed. This one, before we do factor by grouping, we need to do something else. So before we can factor this by grouping, we need to look and see if we have a number in common. What numbers do we have? We have a 12, we have a 6, we have an 18, and we have a 9. So what numbers in common with a 12, 6, 18, and 9? Well, they all have a what in common? Number that's divisible by all of them would be a 3, right? Okay. So we're going to begin by factoring out a 3. Do they have any variable in common? No. right? Because that 12 doesn't have any variable. So all we can factor out is a 3. So factor that 3 out at the beginning. You always need to do that first. Take out the greatest common factor first. 12 divided by 3, that makes it a 4. Negative 6 divided by 3, that leaves you with now a negative 2 cubed. Negative 18 divided by 3, that leaves you with a minus 6 p. 9 divided by that 3, 9 divided by 3 is a 3 p cubed. So we factored out that 3 at the very beginning. Now what can we do? Now we can go ahead and look at this in terms of factoring it by grouping. 4 terms. So let's see what we can do here. The first 2 pieces, they have something in common, so this should work. This order is going to work. I don't think we're going to have to switch things around because I think we can make it work. We'll know here in a moment though. So let's try to factor out the first 2 by grouping. We have a 4 and a 2, so it looks like I can take out a 2, and that's going to now leave you with a 2 minus q. The next 2 pieces, well, it begins with a negative. If it begins with a negative, second 2 pieces, if they begin with a negative, you have to factor out a negative. So we're going to factor out a minus 3. That's what they have in common. So we factor out that minus 3. If I factor out that minus 3, then what's left over? Well, minus 6, divide that by minus 3. Negative and negative, that leaves you with a positive 2. And what else can come out? You about forgot. Don't just take out that minus 3. What else? They also have the variable what? P. So take that P out as well. Sorry about that. Just about didn't look at the variables. But you got to take out that minus 3. You also have to take out that P. So then minus 6 divided by minus 3, that leaves you with a 2. Now, we're on the right track because these match. Okay, they should all match up here. The next piece, 3 divided by minus 3, that's a minus 1. We don't need to write the 1 yet. We took out the P, right? So that left you then with the Q. Are my groupings, the parentheses, are they the same? Yes, so those can come out. And so what's going to come out is a 2 minus Q. Gone and gone. What's left over? 2 minus 3P. And what's still out in front of all of it? Because you don't want to forget that we had to factor out that 3. So 3 comes down as well. Thank you, Josephina. So that would be now our final factored finished answer. Let's look at one more of these, and then we'll move on and we'll look at 5.2, which builds upon factor by grouping. So we'll look at one more of these, and then we'll move on to 5.2. 76. So question 76, we've got 3m squared n cubed plus 15 m squared n minus 2 m squared n squared minus 10 m squared. Take a moment to see what we've got and how this is all going to work together. so we can see it. Okay, now, first thing we need to always look at, number-wise, can I factor a number out? I've got a 3, a 15, 2, and a 10. Is there any number that's in common? No. So no number is going to come out. Now, look at the variables. In this case, there is a variable that's in common. All of these have m's, and all of these have m what? M squared. Okay, so notice how they all have an m squared. So what we're going to do is we're going to factor out an m squared because that's in common. That leaves me then with a 3n cubed plus 15n minus 2n squared minus 10, right? Because that m squared was in common in all of them, so we factored it out. So that's the first thing we do, is we look for numbers and we look for variables in all of the terms at the very, very beginning, and then we go from there. No number was in common, but there was an m squared, so we factored out the m squared. Now we look and we do grouping because we have 4 terms. So the first 2 pieces here, what can I factor out? Well, it looks like these have a 3 in common and an n in common. Because they both have a 3 and an n in common. 3 divided by 3 is 1. We don't need to write it. N cubed, take out an n. That leaves you with an n squared. 15 divided by 3, that's 5. The n's are gone, so that leaves you with a 5. Next 2 pieces. What does it do? It begins with a negative, so we factor out a negative 2. Once I have factored out that negative 2, nothing else is going to come out. Whenever you factor out a negative, that switches your signs. So the n squared stays. Negative 2 and negative 2 is 1. So see how it's gone? So that leaves you with an n squared because those cancel. What about the next piece? Negative 10 divided by negative 2. So negative 10 divided by negative 2. Negative and negative makes it a positive 5. Are my groupings identical? If they're not, you made a mistake. Or you'll have to come up with a different technique. In this case, they are the same. So they can come out as an n squared plus 5. Gone and gone. Write out what's left over. And what is left over? 3n minus 2 is left over. And do not forget, at the very, very beginning, what did we factor out? We factored out an m squared. So that would be your final, fully factored answer. That's as far as you can go. Now we're going to move on, and we're now going to learn how to factor trinomials. And this is 5, 2. And this is, I think, one of the most important concepts that you need for college algebra is how to factor out these trinomials. So we're now going to learn how to factor out these trinomials. We're going to begin just by learning how to do it with multiplication. So we're going to multiply some of these out, and we're going to look for patterns and similarities. If I gave you this to multiply it out, and I said multiply this out, we've done this before. When we factor, it's the opposite of multiplication. Kind of like division, but not really. It's factoring. So if I was to give you this and I said go ahead and work with this one out, multiply it out, you would FOIL it, right? Okay, so let's go ahead and FOIL this out. We're going to do two of these with multiplication, and then I'm going to show you how to do it with factoring to work yourself backwards. Then once we get those understood, then we'll work with ones where we don't know the answers. So let's go ahead and multiply this out. So x times x, okay, x times x is an x what? Squared. Multiplying, we're foiling. Okay, just going to FOIL this out. X times x is an x squared. X times, okay, outside and outside, x times a negative 2 is a minus 2x. Inside and inside is 5x. Last times last is a negative 10. These can go together. And that gives you then x squared plus 3x minus 10. Remember how we multiplied those out. We're going to be working backwards. Here in a moment, I'm going to give you this, and I'm going to show you how to get this. We're going to be working it backwards. But let's do one more just so we can see the patterns. Let's go ahead and multiply this one out. If I was going to FOIL this out, what would we do? And you can draw the arrows if it's helpful. If you want to, you can. We're probably confident enough not to have to, but if you want to draw the arrows, you can. So let's go ahead and FOIL this out. 4x times x, well, that's a 4x squared. 4x times 5, that makes it a 20x. Minus 3 times x, that's a minus 3x. Minus 3 times 5, that's a minus 15. The middles again can go together. And that leaves you then with 4x squared plus 17x minus 15. So that's what we did back in 4-4, right? We FOIL. Okay, now look at what we did. We took this, we FOILed it out. Notice we got the 4 terms here and the 4 terms over here. Then we combined them and we got to this. Now what we're going to be doing here in just a moment is we're going to be doing these exact same problems, but we're going to be doing them backwards. I'm going to give you the polynomial, and then you're going to write it like this with the parentheses. So now let's take these two that we just did, and let's factor these out. So now we're going to work them backwards, and you're going to see how it all goes back and relates to each other. So let's try to factor out the first one here. Let's try to factor x squared plus 3x minus 10. So this is what we're going to be doing in this section. And we're going to see how it all relates back in just a moment. So I'm going to keep that up there so we can refer back and see where all the pieces came from. We want to factor this down. And eventually what we want is that. We don't know that we should get that one. We worked it out backwards, but we're going to take this, turn it into that. Okay, how is that going to work? Well, there are many different ways to factor these out. I like factor by grouping. I think it's one of the easiest ways to keep track of your pieces. So we're going to put the 1 in front. If there's no number, you put a 1. If there's a number, we use that number. So if there's a 5, we wouldn't have to do this. But in this case, we've got the 1 in front. Now, we take the first number times the last number. And we place it in a box over here. So 1 times negative 10. 1 times negative 10 is a negative 10. Now, here is what we want. We want two numbers that multiply to give a negative 10 in that box, and add together or subtract to give me that 3 in the middle. And it sounds more complicated and more difficult than what it really is. So we want two numbers that multiply to give me a negative 10. And add or subtract from each other to give you that 3. In some cases they're going to add. In some cases they'll subtract. Now let's think first about multiplication. So I want to get two numbers that multiply to give me a negative 10. What do we know about the signs in multiplication? How can I get two numbers, just think about the signs, not the numbers. How can I get two numbers that multiply together to give me a negative 10? Well, the only way that can happen is one positive, one negative, right? Because if they're both positive, a positive and a positive would make it a what? Positive. That doesn't work. We want negative 10. Now, if they're both negative, what would happen? Well, negative and negative would make that then a what? Positive again, and we don't want that. So this is a negative 10. So because that's a negative 10 that we want right here, that means then, whenever it's a negative, that one number is positive, one number is negative. So if the number inside of your box is negative, then one number is positive, one number is negative. Now we look in the middle. And look in your middle term, that 3. What's the sign of the middle term? It's a positive 3. So we need to make sure that that sign goes first, because that's our largest sign. So we're going to have a positive, because in the middle is positive, and a negative, because one is positive, one is negative. Now we need two numbers multiply together to give you a negative 10. In this case, subtract from each other to give you 3. Well, 5 and 2 would work. 5 and negative 2. And we can check because 5 times negative 2, well, what is that? 5 times negative 2 is a negative 10. See how that matches in the box. What about 5 minus 2? Well, 5 minus 2 is a 3. See how that matches over there. Now, once we've gotten to this point, we've got our two numbers, then we take the middle and we split it up, because we're going to be factoring by grouping now. So we keep the ends alone, but what we do is we split the middle. So now we've got the x squared that comes down, and we split that 3 up into 5 and negative 2. So we split that up as a 5x and a minus 2x, and the minus 10 comes down. Okay. Now we factor by grouping. We're now going to group the first two pieces together. what can I factor out of the first two pieces? These both have an x in common, so an x comes out. And what's left over? X plus 5. The next two pieces, remember, it begins with a negative, so that means we've got to factor out a negative. So we factor out a negative 2, and that leaves you with an x plus 5. All right, so we've gotten to this point. Now we're almost done. Are these the same? Yes, these are the same. So that's going to come out as an x plus 5 out in front. Gone and gone. And what's left over? X minus 2. That is your fully factored form. Now let's compare that to what we did a moment ago. And I'll just try to put this over here so we can see. What we did was we worked backwards. When we multiplied, we started with this. And we broke it down into this. Notice it's the same as here, right? Different order, but that's okay. But notice how this is the same as that. Different order, doesn't matter. Those got combined together to give you that, which is our original. Now look what we did. We took this, we broke it up. Notice we got the same thing. Then we factored it by grouping, and we got back our original. So see how that multiplication relates to that factoring. You're just splitting it up or reducing it in. Now let's try the other one. Okay, the other one is we're going to try and factor this. We're going to try and factor 4x squared plus 17x minus 15. We're going to do the same process as what we did a moment ago. We take our first number and multiply it by the last number. So I'm going to try to do this one a little bit slower to make sure we see where all the pieces come from. So we take the first number times the last number. And that 4 times a negative 15, well, 4 times a negative 15, that's a negative 60, isn't it? Is everyone okay with that? So you take the first number times the last number. Now, this is negative. And since this is a negative sign here, that tells us then, because it's negative, that one number is positive, one number is negative. If it was a positive 60, then they would either both be positive or both be negative. And we'll look at some of those here in a moment. Now we look at the sign in the middle. And what's our sign in the middle here? Well, our sign in the middle is positive. So that means we've got a positive for the larger number. It goes first. And a negative for the second number. Now we have to find the two numbers. We want two numbers that multiply together to give you a negative 60. In this case, subtract from each other to give you a 17. So multiply together to give you 60. Subtract from each other to give you a 17. Well, I'll go ahead and tell you the numbers now, but later on, you're going to have to try to help me find the numbers. Okay, so this one, how about we use a 20 and a negative 3? Why would a positive 20 and a negative 3, well, why would that work? Well, did these multiply together to give you 60? Let's check that out first. 20 times a negative 3, that's your negative 60. So that checks out, right? Okay. What about 20 minus 3? 20 minus 3 is 17. That is what we want in the middle. Now we can go ahead and get our 4 terms. So we're going to take our middle. You always leave the ends alone, so they do not change. Only split up the middle. And that's now going to split up into our numbers. So we've got a 4x squared that simply comes down. And then we've got a 20x, a minus 3x, and a minus 15. So see how we split that 17 up into 20 minus 3. Because 20 minus 3 is what? Well, 20 minus 3 is 17. Now we can go ahead and factor by grouping. So what can we factor out of here? Well, it looks like these have a 4 and an x in common. So I am going to factor out now a 4x, and that leaves you with a x plus 5. The next two pieces, we repeat this process. It begins with a negative, so we have to factor out a negative. And 3 and 15 have a 3 in common. So I'm going to factor out a negative 3. And when you factor out that negative, it switches your signs. So that leaves you with an x. And negative 15 divided by negative 3. Negative and negative makes it a positive 5. Now we can look and we can see these are the same. And it can come out as an x plus 5. And then what's left over? 4x minus 3. I want you to see how these relate together. So let me move this over so you can see side by side the multiplication. Remember, we just multiplied this one together a moment ago. Look at the terms. Look at how they're the same. 4x squared, 20, minus 3x, minus 15. We FOILed it out and we got those 4 terms, and we combine them together till we get that. When we're factoring, we're doing the opposite. So we took what we got here and we broke it down and we got back our original. See how it all relates together because you get the same 4 terms. It's just that we're, instead of multiplying it to get our answer, we're factoring. So we're taking this and we're turning it into the parentheses. And later on, you'll learn why this is important. Because when we go to solve things with an equals, meaning equations, we have to break down our powers. I'm going to now pick out a couple of these from our textbook to look at. And try to pick a couple of these that look good here. We'll do one of these right now, and then we'll come back and do some more. So let's look at a fairly simple one. How about question 21? And this is on page 355. Question 21. And we'll take a break after this problem. we want to factor this. And when we factor it, we want to get our parentheses. So we want to factor this down and get back our parentheses. There's no number in front, so we put a 1 here. 1 times 56. Well, 1 times 56, since there's no number, we put the 1 there, is a 56. Now, how can we get two numbers to multiply together to give you a positive 56? Well, to get two numbers to multiply together to give you a positive number, how can that happen? They can either both be positive or both be negative, one or the other. So this is a positive 56. So that means either both positive or both negative. So what do we know? We look in our middle, and this is going to tell us what we've got. It's a positive in the middle. So that tells us then that they are both positive. What two numbers are going to multiply together to give me 15, multiply together to give me 56, add together to give me 15? Can anyone tell me what numbers would work? Multiply together to give you 56, add together to give you 15. Okay, 7 and 8, right? How do we know that that would work? Well, 7 and 8, let's check it. 7 times 8, that's 56. And 7 plus 8, that's what? 15. So that works, doesn't it? They work. They add together to give you the 15 in the middle. Multiply together to give you 56. We take our middle, and we split it up again. And that is then p squared plus 8p plus 7p plus 56. Now we factor by grouping. So the first two pieces, we can factor out a p. And what's left over? P plus 8 is what's left over. The next two pieces, what do these have in common? Well, 56 and a 7, they have a 7 in common. That leaves you with the p, and then 56 divided by that 7 is an 8. My groupings are now the same. That's going to come down to b. P plus 8, gone, gone. What's left over? P plus 7. And that's your final, fully factored, finished answer. So that's as far as we can go on that one. Let's go ahead now and take a short break, and then we'll come back and we'll work out some more of these. Hopefully we can get through 5-2 today. There's not that much left. We need to make sure we can get through at least most of 5-2, if not all of them.